if you had a chance to look at today's, or the chapter we're covering this week, I should say. The chapter we're covering this week, the official title, if I can pull it up, is Object-Oriented Thinking. And then it goes and it spends like almost the first half of the chapter just talking about the string class. And that's kind of a little on the weird side until you realize why they're doing it. So what they're doing and what I'm going to try to do and show you is when you start thinking and start coding using an object-oriented programming methodology. Sometimes people will call it OOP or OOP. What it's doing is it requires you kind of change the way you're thinking about some stuff. And so they decided, they said, hey, why don't we take an existing class that C++ provides, in this case, the string class. And it says, we'll take that and we will allow you to kind of really like deep dive into how it works. Because we've already looked at a string class and done some stuff with it. But we're going to do a really deep dive into the string class and look at a lot of different of its methods and the way we use it to try to kind of show how you could develop your own classes by looking at an established class that you're already familiar with and kind of seeing why they're doing some of those type things. So that's going to be a big part of this chapter. We're going to spend most of today on that, just so we can kind of see some different aspects of it. And then we will look at doing arrays of objects in C++, which is going to be really simple. Let me swap that and pull this open, just so we can work with this. Okay. I don't need that. I don't. Okay. But because of the way that it's being taught, I would actually like to start actually with the arrays of objects. So we're going to kind of go a little bit out of order, talking about the arrays of C++ objects instead of doing the string class. The reason why is we've just recently talked about classes. We just recently talked about arrays, so I want to do that before we kind of deep dive into that class. So what I want to look at is, and this is going to be really simple, really easy, is how do we go about the process of creating an array of objects? And the good news is it's actually very, very simple to do. So if you remember, and let me just pull this back up just so you can kind of see. If you look here, we have our circle object that we've talked about before, and then we gave it a variable name, and we passed something to the constructor. Or we created a circle object with a name, but when we didn't pass anything to it, we used that no arg, what they call the no arg constructor, which is meaning that we didn't pass any arguments and it went to its default value, which was defined up here in our circle.cpp file. So we set the radius to 3.5. I can create an array of circles very similarly. So I'm going to say circle. And if I want to create an array of circles, I might do something like array of circles and say 10. And if I do this, I have just created an array of objects. All of those objects are of type circle. And the question is, what have I actually done? So if I go and run this isn't going to give me any errors or anything like that. This is correct. I've said I'm going to take a circle data type. I use my square brackets to specify that it's going to be an array. and then I gave that array a name. But because I didn't call those constructors, each of those objects has the default no arg constructor called. Okay, so if I were coming here and do a little for loop, int I equals 0, I is less than 10, I plus plus, it is cout array of circles, I could specify my index to know which circle I'm talking about. So that'll be I, just like we did before. And then I'll use a method to get the radius. So I have a get method or get radius method. If I run this, you'll see here in the code that runs, every one of those objects use the default constructor. Okay. So by doing this, it works. I have a whole array of objects, but they're probably not what I want. Now, I could turn around, for example, and say, just like I read it based upon an index value, I could say, okay, array of circles 4 equals, and then if I have a set radius, so I say dot set radius, and then I give it a value like 10. If I go and run this, you'll notice I have my default values, then I have a 10, and it is array index 4, which is my 5th element, kind of dab smack in the middle, and it goes about that process, just as you would once again expect. Okay, so to create an array of objects is really simple. It's just like creating an array of anything else. I just specify an object as my data, or my class as my data type, instead of one of my primitives, like an int or a double or something like that. The way I index those objects and be able to access them is I use the indices, just as I did with any other array. And then I use my method or direct access to a property if it's public in order to either look at or change values within that specific element. So that's just real simple how I can create an array of objects. Now, the other thing that I can wind up doing, just as a FYI, is I can create, for example, an array like this. So I'm going to once again specify my data type, circle, and I'll call this one circles. I like to use a plural name for my variable if it's an array, because I have more than one of them. And I'll use my curly braces. They'll say circle, and I'll say 2. Circle 4. Circle 6. Okay. And I could go on and on and on. This is just a quick little example. Well, in this case, if I were to specify circles and make that 4 elements, because I have 1, 2, 3, and 4. Now, if I go and I run this, you'll notice that it specifies my 4 elements. I created my second array of circles, and I see them as 2, 4, 6, and 8, just as I'd expect. So I can create my objects initially either just with the default no arg constructor, or I can pass elements into my constructor and get those values. Now you might say, well, why would I want to even have an array of objects? Well, there's a couple of really good reasons why. Typically, what we've seen so far, because we've not talked about an array of objects, is we've looked at a specific or a single data type, and that can work really well. If I had, for example, a class called student, and I needed to look at one student, um, I would just need that one piece, and then I could go in and I could say, okay, what's their name, and I could update their graduation status, or I could update their class registration, or I could do whatever those methods are that I need to do with them. However, a lot of times I'm not going to look at a student. I might have a whole class of students I need to look at. So I've got 10 students there, or 50 students there, or whatever. And so I might look at my class and go, okay, here's where I have this information, and I need to be able to look at any one of these students, not just a single student at a time. I might need to look at it as a whole class, or maybe a whole major of students, like show me all the English majors, or show me all the business majors, computer science majors, or whatever. So being able to have an array of objects becomes really beneficial when you look at a collection of elements, especially a collection of complex elements. And we talked about a student as a perfect example of a complex element, because you cannot be defined by a single value. You are made up of a lot of different properties, and depending upon what context I'm looking at you in as, if I'm looking at your medical records, or your driver's license information, or your student information, I'll use different properties to properly define you based upon my context. But regardless of how I look at you, you are never just a single value. And so that's why we often need to have those array of objects. Okay. And so if you go through your different uh, elements here, you can see some different examples of how you go through that whole process. Um, anything that you do with an array, that's what you do when you use an array of objects. It's very straightforward as far as that goes. It doesn't matter if you're using a singular element that you just pass in, or an array. It's just like you use arrays. The difference is it's an array of object and how you perform it. That includes things like passing or passing the whole array to a function. Here we see get total area of all of our circles. Or if I want to pass a single element of an array, I can do that by giving it an index as well. So that's just really quickly kind of how you look at using elements in C++, or objects in C++ as an array, or an array of objects if you prefer. Okay. Any questions on that before we move on to our strings and looking a little bit more deeply at our strings? Okay. Just as an FYI, they made a change, and I need to stop sharing real quick so I can find it. On my screen, I think it should be the same on yours. If you look at the bottom, where it's kind of like a list of items there, you should see near the last one on the right-hand side of a collection is one called reactions. And that should be able to give you like a thumbs up. I don't know if you can see where it has mine. I see a little thumbs up on that. So we can do that if you guys have, if I say, is everyone okay, you can kind of give a thumbs up, and I'll be able to see everyone there at one time. They have a clap. They don't have a raise hand one, like say, hey, I need a question. So you'll still just need to unmute and do that.
There is a raise hand one in the chat.
Okay.
Or like in participants, there's a raise hand button.
Okay. In participants, there's a raise hand one. Okay. That's good. So I don't. So that's gonna be my question: is it just because I can't see it because I'm the host? And,
I will click it and see what happens because I've never clicked it before.
Oh, I see it. Perfect. Okay. So I
There's
don't
also
know if,
yes, no, go slower, go
oh,
faster.
you
And
guys
then
have all,
there's dislike, like, clap, need a break, away.
wow, okay, you guys get a lot more than I do. Now I'm kind of envious. I shouldn't be envious, but I am. Okay. So yeah, feel free to use those reactions if you guys want. I forgot to mention that last week when they rolled out some of the new stuff to Zoom, but that's kind of cool. So feel free to use that. That way I can see if you post something in chat. I unfortunately I can't see it. It doesn't like ding to let me know that it's there. All right, let me go back to sharing my screen. Let's talk about the string class. Okay, so we've looked at the string class. We've used it a bunch. We talked a couple weeks ago about how there's actually two different types of strings in C++. There is what we call the C-style string, which is actually an array of characters that is then null, what we call null terminated. It just means that there's a null character at the end of our string. That null character is very important because without it, a lot of the functions that were designed for that C-style string, they look for and they use that null character. If that null character does not exist, then it has an issue. Then C++ came out with a string style object, and that string object provides a lot more functionality. I think everyone agreed that it was a whole lot easier to use. You didn't have to worry about some of those other things. And we saw a couple different things about it. So one of the interesting things that you can do when you are creating a string object is you have string S1, and this is how we do it a lot of times. We say S1 equals, and then we put in quotes our string. But there's another way we can do it, and that is to say, like the second one, S2, this is a string. If I come here, let me just come back here real quick. Both of these do basically the exact same thing. And if I go and I run this, we're not going to see anything because we're not printing them out. Oh. Oh. There you go. Nothing's being printed out. That's fine. But we've still created these two strings. Here's an interesting question for you, and I'll just kind of pose this. These are not created equal. Even though the strings say the same thing, these two strings are not created the same way, even though we're creating them at the same basic time, we're only one line off. But these strings are not equal, they're not created equal. They're not, in the way that they're created, equal. So if I were to go and say like an if and say S1 equals S2, it's going to come out okay. That's fine. But they're handled differently. And so let's talk about what's being done. If you looked in the notes, and you saw it when I was pulling this up, S2 is actually a more efficient way to create it. And the reason why is S1 is created, and it uses its no arg constructor, and then it gets assigned a value. With S2, that value is assigned as it's being constructed, and so it performs one less step. And so S2 is more efficient because it doesn't need the extra step to go in and work with it. Okay, so just as a kind of an FYI, not only do we have two types of strings, but in our string class, we have two main ways of creating our string. Okay. Excuse me. All right. The string methods that we've looked at so far have been basically like size to get how long our string is, and the at method. The at method is very simply, I just need to know what character at a specific index is. As long as the index I pick is less than my string size, it's okay. So if we look at this real quick, if I want to say like cout s1 dot at 5, it's going to print something for me. But if I say cout s1 at 50, I can pretty much guarantee that I don't have 50 characters in that string. If I go to run it, boom, I get an error message. And if you look, it takes me to the line that the error occurred on, unhandled exception, and I get an out of range at memory location. Okay, so I went beyond where there was data. And because I went beyond where there was data, I got my hand smacked. Okay, so that's kind of the limit as to what we see here. I have, for the part that did run before there was an error, you see that it gave me the character I. Because if I go 0, 1 is T, 2 is I, 3 is S, 4 is a space, and then 5 is again another I. So that's kind of how it's processing through that step. It's kind of like with an array, zero-based indexing, and so it's the 6th element, which is why that one came up. Okay. Well, let's look at some other methods that are available to me. The first one we can look at is the append. And a lot of times the append or its similar method, the assign, is essentially what's happening here. It creates S1 and then assigns the value. And as append and assign do very similar types of things. So let's look at what we have here. If I say S1 dot append, I can say, hope you like them. And append is going to append this string to the end of S1. If I take the assign to S2, assign is going to replace the whole contents and make S2 now equal this has been changed.
Would that work for S1 though? Because S1's a different type of string, and you're using the other type of string.
Yes, it will, and I will show you why in just 1 second. So S1, even though we assigned it the same way we do a character string, it is still of the string data type. And because it's a string data type, I have the ability to use append and assign. Oops, I use append both places. So I can use both append and assign on either one of these because they are both a string data type. If it was the char array, which is kind of given the same thing, it looks similarly when we create them, that would not work. You have to use the string copy command in order to copy a value into it. So if that's what you're remembering, you would be correct, except for the fact that we are technically using the string. If I run this, and this will hopefully help you kind of see why the first one was there, both of them start off with this as a string. I called append, and it now says, I hope you like them. It's appended to it. However, this is a string has been replaced with, this has been changed in S2. So S2 gets the assignment. In line 14, where I say string S1, I create an empty one, and then I essentially, behind the scenes, if you would, I called the assign method and assigned it this is a string. So because it is a string, I can call this assignment operator anytime I want and just change its value. Okay. So I can do it with the equal sign, or I can do it with the assign value, or assuming the assign method. The append method, I used this one where I just append a string. However, I have 3 other commonly used append methods. And what we want to show here is that just like we've already seen with constructors, any method inside of a class definition can be overloaded. So in my first one, I take the whole string, I pass it into my first string, and I append it. However, I also have a string with an int index and an int in, and it kind of wraps right there. It makes it a little hard to see. So what that does is it appends a number of characters from string S starting at my index position. Okay, so what does that mean? Well, if I come back here, I see append, I have a string. This appends the whole thing. But I can also specify which is my first element and how many of them do I want. So I can specify a count. So I can say 4. And you know, so I say this is a string, and now it specifies hope. I start at my index 1, which is my second character, and I just copied 4 characters in. If I have just one number instead of 2 numbers, I say starting at this index. So I could say this is 5, 9, I think 10 will be my right one. Hope you. Okay, so I grab the first number of characters in there. So I grabbed just enough to just do the first 2 words, which is what I was looking for. And that's another way of doing it. So I can say, okay, I'm going to grab something starting here and go this far, or I can say, if I only pass one number, I can say, give me the first X number of characters. And it gives me a little bit of different ways to handle my value. I can also specify a number of times I want a character to be copied and then pass in a character. And by passing in an actual character, so not a string, an actual character, that one character can be repeated over and over and over again. It will in fact be repeated in time. So whatever I put there for in, then it will be repeated. A good example of something like this, you might have seen, like, for example, a table of contents. And a table of contents will have a chapter title or a subchapter. It'll have like dot 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 until it gets to the far right hand side, and all the letters then, or excuse me, numbers for the page numbers where those section headers or those chapters start will be put in. Well, I could, if I wanted to, use this fourth append method to say, do some calculations. Go, oh, I need to have 18 dots, and type in 18 and use a character or dot, and it'll just append ding, 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 all those little dots so that help line things up. Anytime you see like a line or dots there, it's helping you create a visual line so you can connect the title or section or whatever it is with a page number, so that way you can jump to it faster and easier. If I didn't have that, optically, I could easily move off a line or two and get to a different spot. So that's just an example of where you would use something like that. With appending a string, like you said, we've got 4 different common methods. They're overloaded, so I call the same method and it just works. Okay, let's look at inserting and replacing strings. You might say, well, didn't we just insert a string? Yeah, kind of. The difference is append puts the string, the new string, at the end of my existing string. Insert will insert it into the middle of my existing string. See if I can. Okay. We'll comment that out for just a second. Comment these out because we don't need them anymore right now. Okay. So I have a printout, welcome to my world. Here I do s.insert. I insert at index 11, and then I say, what do I want to insert? So this lets me go kind of anywhere in the middle of my string I want and add a value. So in this case, it says, welcome to my world. It doesn't have to be at the that end like the append is. It can be in the middle. So that's the difference between insert and append. Okay, replace is a little bit different. So replace says start at an index, replace X number of characters, and then put in its place this word. Notice that I'm specifying 5 characters here. However, life is only 4 characters. So if you were to work this out, you would see welcome to my, and then the space, this is character index 14. World is 5 characters long, so it's going to wipe that out and insert into their life. So it's kind of, the replace is kind of like a find a location, delete X number of characters, and insert a new piece of information in there. If I run this, you notice that originally it says welcome to my world, it changes to welcome to my life, and then once again, because I have the insert, it's welcome to my life. Okay, we can see this example right here. All right. Any questions going forward? If you're good, just kind of thumbs up. That way I know. Let's see if I can see this. Awesome. Got 2 thumbs up. Everyone else is getting a soda. It's okay. I can use one myself. All right. Come back here. Okay, so that is the insert and replace. Notice that, like I said, with the replace, it's almost like you're doing a couple different things. What's interesting is we're going to see in just a second how we can remove data. And because my methods inside my class, my object, when I define it as a class, I can call other class methods. So that replace could very well, behind the scenes, call the erase method to erase out a section, and then call the insert method to add it. I can logically see why to do it. And so the part that I want to show you, the first part was that we can overload our methods. This part is I want to show you that, hey, not only can I call a method, but as a developer of classes, my methods can call other methods of my own. I don't have to worry about it, though. I am abstracted. I am from the end developer. So when I'm defining a class, the person who's going to use my class should not have to care about how do I do it. All they need to concern themselves with is, does it work? And hopefully, is it fast enough? So keep this in mind. When you build a class, you might go, oh, I don't need to worry about this. I can X, Y, Z. A perfect example of this, and I was very happy to see that this was done. Someone came to an office hours a week or two ago now, and they were talking about when the array assignment and how you're supposed to find the total of the array and then the average of the array. And so they had started to kind of calculate up the total, and then they're going to divide it by the number of items. They said, well, wait a second. I've already got a function to calculate my total. Can I just call that function? And I told them, yes, you can. And so to reduce the amount of work that they would have to do, they called an existing function. And I can see as a class developer, them doing the same thing with that insert uh, method. Is they're just saying, hey, I've already got a method that does, I got two methods that do what I needed to do. This is just a little shortcut, but behind the scenes, I'll just call those methods. That way, it's a little bit faster and more efficient for me. So don't be afraid to use those types of logic to simplify your life. You don't get any points for doing it the hard way. Okay, so we talked about inserting, replacing, we talked about appending, and the things that are surrounded with that. Now, let's talk about string sizes, and this one's a little bit different. So sometimes you need to have methods that do a same or similar thing. This is a perfect example. Length and size are actually what they call an alias. So those are two methods that do the exact same thing. Length and size do the exact same thing. They specify how big is my array. I then have an interesting aspect for my um, string class called capacity. And you might say, well, isn't capacity like how many characters are in there, which means that length and size and capacity are all the same? And the answer is actually, believe it or not, no. Capacity says I've created a internal element where I'm storing my data, and as long as I don't go bigger than that, I don't have to redefine and recreate. I can just keep on using this. So capacity says how big is my buffer, i.e., can I put more text in without having to go through a memory management process. It is always going to be at least the size or length, if you prefer, of your string, but more likely than not, its capacity is actually going to be larger. So you might ask, okay, well, why would I bother to have an alias? Can't I just use length, or can't I just use size or something like that? And the answer is yes, you could. And as a class developer, that's always a choice that you can make. However, this is kind of the big thing. Let's say that you were used to using you find out that most of your developers that are using your class have come from other classes, and some of them called their string manipulation or the how many characters are in it as size, and another set called it as length. And so if you say, well, you know what, in this case, I'm going to create two different classes or class methods that do the same thing, then those two groups of people who are using it both kind of feel comfortable with what it is because it's similar to what they've done before. And so sometimes you will create methods that do the same thing simply to help accommodate your end users. So don't be afraid of that. That's a semi-common thing that you can do. Okay, let's talk about removing data from a string. There are three methods that you can use. They all do things slightly differently, even though they, at first glance, have similar names. Okay, so clear and erase. Let's talk about that real quick. Clear is going to delete out my entire string. Erase takes two parameters and will delete a part of a string. So here I have S1 and S2. They're the exact same thing. So S1.clear. Notice that it does not take any parameters. And that's because clear is going to completely erase my string. S2, on the other hand, with erase, is going to take two parameters by default. The first one is going to say, at what index do I start? And the second one is going to be for how long. So if I say 5, 2, this is a string. Then I have a blank line. That is my empty string, okay, because I use clear on it. And then I have this is a, or instead of saying this is a string, it's this a string. Okay, so you see how with clear, it completely wiped out my string. With erase, it erases just a little part of it. Now you might say, well, what about empty? Well, empty is checking to see if the string is empty. So if I say cout s1.empty, oops, and then s2.empty, what you're going to see is 1 and 0. 1 is an integer value that C, back when we used C, we did not have a Boolean data type. 1 was considered to be true. 0 was considered to be false. In fact, technically, 0 was false and any non-zero value was true, usually 1. And so we see when we call the empty, it's returning an integer value, 1 for true, 0 for false. So empty doesn't empty out our string like you might think. It is checking to see if it is empty. Now, if you remember from last week, we talked about when we create a class using getters. Getter was something that would allow us to say get radius, for example, and was allow us to pull back a radius to see how big was our radius that printed out for us. So empty should, in my opinion, actually be called is empty, because whenever we have a getter that's checking that a Boolean variable, which is this is essentially what it is, a lot of times use is instead of get. And if you don't use is or get, as you can see, empty is a misleading name. It would make you think that it would empty out the contents of your string. So whether or not they'll make that change in the language at some point, I do not know, but I definitely think that it should, and that's the reason why it should. Is I think to me, it's that little bit of confusion. So when you're building a class, make sure all of your getters, even your Boolean values, or excuse me, Boolean variables, have a get in a variable name or an is in a variable name. I think it just makes it a lot less confusing and a lot easier for your end developer to use if you have good, solid naming conventions. Okay. You can go through your process and compare strings. There's a couple different ways that you can do it. So a lot of times, instead of using like a less than or greater than type thing, you'll use a compare method. And the compare method's a little bit weird because of how it works. And so let me copy this in here just so you can kind of see what it does. I have two strings. One is welcome and one is hello. If I say S1 to compare that to S2, what's actually happening is looking at S2 and saying, okay, is S2 bigger than or less than S1? If I go and run this, you'll notice that I have S1 dot compare to S2, so I'm comparing welcome to hello world, and I get 1. 1 means that welcome is a bigger value. You might say, well, how do I determine a bigger value of my string? Now, there's a couple different ways that you can do it. One of them is look alphabetically, and all my A's are first, then my B's, then my C's. That means D is bigger than C, E is bigger than D, F is bigger than E, etc. If I look at S1, compare that to S2, W comes after hello, and therefore it's bigger. When I compare S2 dot compare to S1, then I get -1. That's because S2 hello is less than welcome. And then I just said, hey, what happens if I pass in a literal string? So S1 dot compare to the literal string welcome, and that gives me 0. That's because those two are the same. It's not the same object. We're not saying that. We are simply saying that these two values are the same. So anytime we have compare, 0 is the equal, gives me the fact that the two are equal. -1 means that the second string was, so your initial string was smaller than your first one. S1, or excuse me, +1 is that their first string was smaller. So that's just kind of how that works. It's a little bit different because, like I said, a C++ Boolean variable, 1 is true. So you just have to make sure you're doing your right test and check on that to make sure it's going to work the way you expect. This also is just where, especially if you are building a class, you need to test it extra because you want to make sure that it's the way you're expecting it to be, for lack of a better term, that it's doing what you want it to do. We talked last week, if I remember correctly, about kind of what we call the sniff test. Does this data seem right? Yes or no? Hopefully it does, in which case you get those types of values. But the compare is a little bit different, so keep an eye out on that. All right. Any questions before I move on from the compare method? Okay. So we talked about the @ symbol, and it's not the @ symbol, the @ method. The @ method is used to get a single character from our string, and that's great. It works really good. There are times that we need to do this for a lot of different reasons. But what happens if I want to grab a section, a whole section? Well, I've got two different ways I can do this. Both of them use the substring method, and it's once again overloaded. So the first one is that I want to grab all the letters after this particular index value. Okay, so if you have string s, welcome to my world, and say s.substring 15, it's going to print out world with a period. And that's just because 15 is where that space is before world. So it's going to say, okay, erase that, and let's go on from there. The second option is I can pass in two variables. The first one is going to be where do I want to start my index, and the second one is going to be how long do I want to proceed. So I may not know how big it is exactly. I'm just going to kind of take a random guess and get that value. Or maybe I don't want everything from the end. I'm only looking for a small piece. This is a good way to get it. Anytime we talk about substrings and getting a substring, this naturally changes into searching for a string. A lot of different ways to search for a string. There are 4 overloaded methods that we're going to look at. Find is the most common, where we just pass in another string object type. Of course, I can use find and pass in a string object type and then an index, and it will only start looking after that index. So I'll show you that in just a minute. Now, with my find, those two look real familiar. They're very simple, but I also have 2 more finds I can use. However, in that case, I'm using a character or set of characters, not a string. So this is where I'm using maybe an array of characters. Maybe I'm using a single character to find that, etc. With that in mind, I can also return or use the index to say, hey, find me the first character after position X or position N or whatever I want to think about that. Okay, let's take a look and just so you can kind of see what this is like and what it means. So S is welcome to my world. S.find is my, and it says, okay, at the 11th character, that's where you can find your substring of my. Now, I know that this is my 11th character, and so then I pass in find and say 20. It says start looking at index 20 and see if you can find it. If you can't, it throws a nasty number at you. You go, huh? Where did this come from? Then finally, I have an example where I'm looking for, instead of strings, I'm searching for characters. Is this character involved? There's a lot of reasons for doing a character versus a string. We won't talk about them at this point right now. But you can see how even though you have 4 methods, 2 of them are basically duplicated because they're using characters instead of strings or vice versa, depending upon how you look at it. So when you're building your own class, or classes, if you would, you can look at overloading your methods just like they did with that find method. One question you ask yourself, though, is, okay, if I've overloaded this method, is it because I just want to overload it or because I'm doing something different? And in this case, you're doing something different. You're using different data types. So being able to work with that is very, very powerful. Okay, our string operators, we have several of these that you can look at and you can use. I've created a nice little table here, at least hopefully it's nice looking, table for you to look at and use. You have a @ symbol, or excuse me, you have I can access things through a square bracket, which is very similar to the @ symbol. I'm looking at a single character at a time. As long as I don't go beyond what my index is, it still works. I can assign the value to another string using the equal operator. So remember, I said that the assign method might be called the same thing as the equals or vice versa. When we talk about assign up in here. So that's where it can be doing that, because you can actually, in C++, one of the interesting things you can do with it is you can overload its operators. So those characters like the plus symbol, minus symbol, asterisk, etc. So that's one of the things that it could be, could be doing to make that work. You got the equality, which is the assignment. Concatenation is going to be the plus symbol. So concatenation is just taking two strings and joining them together. If I use plus equals, I append the second string to the one that's on the left-hand side of that plus equals. So plus is append, or excuse me, is to concatenate two strings together and put it into a third. Plus equals does the concatenation and the appendment in the same step. Okay. Your left and right double arrow keys, we've seen these before. For example, cout and cin. Okay, that's how those work. And then I have my relational operators. My relational operators is if I want to check to see if, instead of using compare, I can get a Boolean value out of a operator. And the downside to this is that I then need to check and see, okay, we weren't equal, so now I need to see which one's bigger. With the compare operator, that's all kind of built in. With the operators like these, I would have to run multiple steps. So it just kind of depends upon what's the best for you that you want to use. Okay. Two more things, I think. Yep. Two more things just to kind of work with these. We are, just as an FYI, we're not going to look at the operators and how to override operators, at least not right now. That's kind of more of an advanced C++ topic. It's really cool that you can do it. It's not always a good thing. So we'll just work with that later. Okay, let's look at the string stream. So this is a special class that has some very unique uses. And one of them is making it very simple for us to convert numbers into a string. Okay. So if I look at this, you can see that I'm using a string stream. And I define my object here. The object name is SS for string stream. And then I assign string stream. I insert it into my stream using my double arrows. And I give it a numeric value. From that numeric value, I then add string to, I say ss.string and assign that value to a new string. There's a couple things that you need to know about this, though. Number one is I have to include my string include header. It's real simple. If I come up here, you can see it's done already in this example. Include S stream. So that's short for string stream. To do it, I'll just take this. Okay, and I can use cout S and L. So if you remember correctly, when we started talking about cout and cin and stuff like that, we said that your streams while these were console streams, there are other types of strings. Then a couple weeks later, we looked at file streams. And here's another one that we can use to help us manipulate strings by letting us kind of work with the stream and how we do that process. But the stream can be used for more than just converting numbers into strings. It obviously does a great job with that, but I can do more. A perfect example of this is going to be if I want to split my string up into multiple data points. So splitting a string is usually done on, for example, a index like a comma or a space or something like that. Okay, so I have some text in a string, and I pass string stream to. I create an object and I pass the text to it. When I do that, it then says, okay, I'm going to be able to do different things. I'm going to use a while loop, and I'm going to say SS. And notice in this case, instead of going in towards cout or in towards my string stream, I'm taking this stream and I'm saying, okay, go out from the stream and put it into this variable. This variable is another string called word. When I do that, I can then take a whole sentence and break it up into small little chunks if I need to do that. So that's just kind of the way the string stream works as far as that goes. Any questions on that? Okay, so those last two things, that those weren't really dealing with the string class, but this is as good a time to kind of talk about them as any, because it lets you see how you can have helper classes in classes that do work with other classes. So those are some of the things that we'll be looking at going forward, and as we progress through them. Hopefully you've kind of seen some different things that C++ does with the string, why it's doing it, and hopefully it'll help you when you start working on building your own strings, your own classes, about what type of methods you would want to add and create and work on, stuff like that. So do keep those things in mind, kind of in the back of your head, if you would. We'll be doing a lot more with classes, not only in this class as we finish it up, but also in other classes, like when we start looking at data structures, which is a class your sophomore year you take. That's a real important thing to understand as far as that goes. Okay, if there's no other questions and stuff, we're done just a few minutes early today, and you can feel free to drop off. If you do have questions, I'll be more than happy to stick around and answer any questions about this or homework or anything else that you guys might have. Otherwise, I hope you all have a great rest of your day, and I will see you on Thursday.
You have a good day too.
Thank you.
Bye.